Once team is formed, we could define the problem statement as a team. We could have better understanding on the problem by asking several questions. We could use 5 wives and 2 husbands approach in asking. Ask who, what, why, when, where, how much, and how often. Who, we ask who reported the issue. What, which product. What type of problem is, against what is not. Description of non-conforming, failure mode or symptom. Why this is a problem. Sometimes this question will help customer to understand what they need, instead of what they want. When it was seen first time. How long it has been there. How it happened, under what situation. For example, is it happened only under high temperature test? Which date code, or lot number? Where it was detected? Which machine, which process, or which module? Where is the failure location? How much, what is the magnitude of the issue, what is the failure rate? How many quantities affected? What is the financial impact? How often? Continuously, or consistently seeing the issue. Or without any pattern, where defect happened randomly, comes and disappears. Or cyclical. For example, only happened at night shift. These are examples of the write-ups for problem statements. Customer XYZ reported their production line detected 2000 dpm, dimension A, of product screw 123S, below spec limit of 1.0 inch, for batch number 789. Second example, customer XYZ reported their temperature cycle test, detected 3 out of 5 units, with no power on failures, for product 456, which built around September 1 to 7. While writing problem statement, it is important to distinguish between perception and fact. We write problem statement based on facts, not perceptions. For example, James is not a good team member. Is a perception. If James heard what you claimed, he might upset with this. He might even complain this to your HR department. And you might not able to defend this. But if you rephrase that to, James was late for 3 consecutive meetings. Then it becomes a fact. And James could not challenge this. Another example. Peter is a lazy boy, or, Peter is stupid. All these statements are perceptions. What is meant by lazy? How we define lazy? If teacher always makes statement, that Peter is stupid, and if this being heard by the parents could complain the teacher to the school authority. But if we rephrase our statement to, Peter has been not submitted the homework since last semester. This is fact. But it is not okay to say Peter is stupid, which is perception. Similarly, our quality was getting worse recently. Is a perception. It might just a feeling of quality manager. To turn this into fact, instead, we should say something like, average test yield was around 90%, versus goal of 95%, since January 1 till 15. Let's have a case study to help you understand this. Say, you have a customer XYZ, reported products could not be powered on. Your FA, failure analysis team, observed cold solder symptom, on the PCBA solder, from the returned products. For this case, what is the problem we want to solve here? Could not be powered on, or cold solder symptom. Suggest you to hit on the spacebar to pause the video now. Spend a few minutes to think through your answer, and why, what is the justification for your answer? So, what is your answer? If your answer is cold solder symptom, that means you assume, could not be power on is caused by cold solder symptom. But is it a fact, or perception? In actual scenario, especially during quality crisis, most of the time, 8D team will have meeting every day, if not twice per day. All team members are following up the progress closely. Everyone is tension. The failure analysis team will report out whatever newly observed, and provide the first-hand info. If observed cold solder symptom on the returned units, they will see this new observation as good news, and can hardly wait to share the latest finding to the team. Though at that time, they might not yet have time to prove that the cold solder is the root cause for the power on issue. If 8D team treats cold solder issue as their problem statement, it is fine if it is the actual root cause. If not, then the team might end up solving the wrong issue. It is risky to jump conclusion and describe problem statement based on perception. Then, you might ask, how to prove that, whether cold solder is the root cause of power on issue? There are few ways we can do this. 1. Is through the analysis of circuitry design. Have the circuitry design engineer to study, from theoretical point of view, is the open joints on those specific pins, could cause power on issue or not. At the same time, rework the board by touching up the solder, to ensure electrical continuity. And confirm if the power on issue gone away and the product function as normal. On top of that, use one gold board. Gold board means, a confirmed good board which used as standard for reference. Lifted up the pin of the gold board to disconnect the joint, and check if we able to duplicate the power on symptom. If all above give us positive result, then we can pretty safe to conclude that the cold solder caused the improper joint which lead to power on issue. Let's have another case study. Let's change the scenario a bit from previous case. Customer ABC reported products too warm after operated for 10 minutes. Your FA team confirmed cold solder symptom on a specific component leg is the root cause. FA team also observed from returned products that there is obvious rework symptom on the leg. So, what is the problem statement for this scenario? Too warm after operated for 10 minutes. Or cold solder. Or rework issue. Suggest you pause the video now, to give yourself a few minutes to think through your answer. Please provide the justification for your answer too. Feel free to provide your answer, and inputs in the comment section. Please click on the subscribe button below this video too. When hitting 1000 subscribers, I will create a short video to discuss this. It is okay to interview the external customer, to understand the problem. You can even set up a formal session with them to get more clarity. Sometimes, customer might accumulate up the random failures for a period of time, and then return all together to you, for failure analysis. If this being so, you might observe the returned units are in multiple failure symptoms or defect types. For this case, suggest we break the issue into multiple smaller issues, and resolving them separately, one by one. One of the powerful tools, to help us having better understanding, of the issue, is versus is not table. This related to the 5 wives, and 2 husbands questions we discussed earlier. We asked the 5 wives, and 2 husbands questions in both positive and negative way. For example, who is affected by the problem? Who is not affected by the problem? Or, who observed the problem? Who did not find the problem? For what? We ask questions such as, which product was affected? Versus, which product was not affected? What type of problem is it, in term of product characteristic against spec? Versus, what product characteristics or parameters are not out of spec? What symptom does have problem, shows physical evidence? Versus, What symptom could be the problem but is not? What was happening with the process? Versus what could be happening but is not? 4. Why? We ask, why is this a problem? Why is not a problem? 4. When? The questions are, when was the problem first noticed? And since when, for how long, has the problem been noticed? Versus when could the problem has been noticed but was not? The following question for when is focus on test condition. How it happened, under what situation, for example, only happened under high temperature. Versus test under what situation does not have problem. Lastly, ask question related to date code, or lot number. Which date code, or lot number affected? Versus which date code or lot number not affected? Next, is where it was detected. Versus where could be the problem detected but is not? These questions, we focus on test, or inspection gate. While the next questions, we focus on machines, which produce the affected products, that is, defective products produced by which machine, which process, or which module. Versus defective products not produced by which machine, which process, or which module. Lastly, the questions focus on section or which area of the product. Which location of the product has the problem? Versus which locations of the product do not have the problem? How much? The questions are to find out the magnitude of the issue, how high is the reject rate, and estimated quantities affected by the issue. How much is the problem causing in dollars, people and time? Whereas, the negative question sounds something like, how many could have the problem but don't? And how big, many customers, could the problem be but is not? While asking these negative questions, we also should ask, any hypothesis for this? What are the facts or observations against this? I will come to share the sample of is versus is not table. You will have clearer picture later on what I am saying now. Lastly, how often? Here, we try to find out what is the trend. Gradual, continuous, abrupt or random, cyclic or periodic. Has the problem occurred previously? Whereas, the negative question sounds something like, what could the trend be but is not? Same as how much. While asking these negative questions, we also ask, any hypothesis for this? What are the facts or observations against this? If you think that it is more appropriate to reassign certain question into other category, such as, reassign question defective products produced by which machine, roll under what category? Or, maybe you think that it is more appropriate to rename, where, category, as which. By all means, go ahead to do so, as long as the way you categorize them, help you to remember the questions. It is worth to point out that not all the questions listed here, are applicable to your specific problem. Use this questionnaire as a guide, and only ask those questions relevant to your issue. This is the sample of is versus is not table. Who? Let's assume, Honeytime is your customer, who reported the issue. They found low power on a product, named product 123. While other customers who use the same product, did not observe the problem. Hence, we can make a distinction here, that problem was only detected by Honeytime on product 123 only. 4. First what? Let's focus on which product. Product 123, is the only product reported with the low power issue. Honeytime bought product 789 too but did not observe same problem. Second what? Related to spec. Power consumption is higher than spec, while other parameters meet the spec. Next, what? Focus on symptom observed on returned units. Cold solder was observed. Anyhow, not all products with cold solder have the problem. Here, the distinction is: cold solder might just a symptom but not the root cause. The last what? Focus on the process condition, at the time building the affect products. Tracing back the record of the machine temperature, when the products were produced, the temperature was near to lower spec limit. At the same time, no mechanical damage observed. No evidence showed the problem was caused by handling. Next, is why. Why is this a problem? System failed after operated for 2 hours. Though, the products passed all internal tests during production. Distinction question. Gap in test coverage. Next, WIFE, is when. First seen by Honeytime on July 4th day shift. Problem gone away after switch to other lot code. Failed and was detected by Honeytime's OOB test, under high temperature. Anyhow, did not observe failure at Honeytime's OOB test, while was testing under ambient temperature. Affected lot code is 444. Lot code 666 did not see similar problem. Seems like something change in lot code 444. Next, is questions related to where. The issue was detected at Honeytime's OOB test. Anyhow, the products passed all internal tests during production. Next question, related to where, is to study if there is any commonality in term of machines, or process, which building the affected products. Defective products produced by machine A and BB. Anyhow, only machine A and BB used to produce product 123. Hence, we could not conclude that the problem was caused by the machine A and BB since defective products produced by all of them. The last where question is related to which location of the product has the problem. Cold solder was observed at location L2, L3 and L4. Locations other than L2, L3 and L4 did not have cold solder. How much? 1 out of 103, 1%, defect rate as reported from Honeytime's OOB test. Anyhow, not all products from lot code 444 failed. This caused Honeytime to perform 100% OOB test. What is the hypothesis? That other customer did not observe same issue. Other customers might have same problem but not reported due to not performing high temperature test. So, the problem might impact other customers too. Lastly, how often? Abrupt spike, since problem first time reported by Honeytime, though products have been built for 8 months. No change in OOB tests since day 1. Hence, we could rule out the issue was caused by the test change at Honeytime. Something changes in lot code 444. By answering all these comprehensive questions, actually you already on the halfway to resolve the issue. If you see value in this video, please click on the thumb up, and share. This definitely will motivate me to make more quality video related to this. Please click on subscribe too, this will ensure you would not miss any subsequent videos. Before we end the session, let's close our eyes, observe a moment of silence, pray with your own respective religion. May the community full of peace, and may the world free from disasters. Looking forward to see you in next video. Thank you.